let's go through the code 410. To be array large sum. And for this question, it gives us an integer array announce and also a k. It needs us to split the array into k non-empty subarrays. And the largest sum of any subarray is minimized. So for example, 7, 2, 5, 10, 8, if k equals 2, and trying to separate it into two parts, that is 7, 2, 5, 10, 10, 8. So you'll see the first part of the sum is 14, second part of the sum is 18. So the maximum is 18. And if we have some other separation, for example, 7 or this, right? So you'll see the later part will be bigger than 18. So the smallest largest is 18. So for this question, one of the things that for the array split, it is consecutive. That means we have to split, for example, this part and the rest of the part. We cannot select, for example, 7, 5, 8, like this way to select, right? So if we can, it's not just so for array we just need to divide to different parts, right? It's just a subarray, not a subsequence. If a subsequence, there is another question that is 1, 2, 1, 7, 2, 3. That is a bit different to that. For subarray, it will be pretty easy. For this kind of range, right? We can do. We know we are trying to find the minimal max. So we know we want to find a range, right? Which can divide the range into k parts. And for if we put the numbers consecutively in this kind of range, it will be less equal to k, right? So we try to find a range. We know this range, the minimal size. We can do well, let's talk about the minimal size later. But the maximal size is that we can have a range, for example, to be the sum of every numbers, right? And we can do the binary search finder to see if this kind of range we can put the numbers into it consecutively in less than k. If less than k, that means this kind of range we can get smaller. If it's larger than k, that means this kind of we can consider this a container. That means the volume of the container is too small. We need to get this value to be bigger, right? So we can do binary search for this, and then we count this number one by one. So let's begin to write code for this. So we are going to have, for example, int min plus their max plus their, and for int nonce max equals max dot max transfer to none. Okay, so we know the worst case that is we put, of course, this max you can use integer maximal. It will not get things towards just several more times calculation if we do binary search. But if we do every number in 1, right? So that means all of the numbers can be put k equals 1, right? So that means we can get this one smaller. We know at the minimal will be at least smaller than this max. The thing is that here there is one tricky thing that the minimal we cannot use 0 to do the binary search, because if we do the binary search what we search about is that it may get some number which does not cannot meet those kind of numbers to k parts. So in order to put that into k parts, that we need at least the maximal numbers to be put into this container, right? So we can do this, the minimal first max mean no, right? So this is important. Otherwise, it will have some errors. Yeah. So let's do the binary search. Input start equals to min and equals to x. Start plus smaller than n int need equals to start plus and start right up to right. We are going to write a function, have a function if can split. So we'll call is valid. Okay, it's valid. Nonce. We can we have a k part and also target, right? That means our the container is too big, right? We can get container smaller that will have end equals new else. Have a start with new. And we are trying to find the smallest container, right? So if we at the end that is one index ahead of the head end. So let's say if is valid start we just return sorry nonce and start we just need to return start, otherwise you just return okay. So we need to write the help functions private boolean is valid. So we just need to count, right? Count this kind of things, trying to see for this target whether we can have less than k. Let's try and see read k int target. So we'll say int count equals 0 for int none. Let's do this. Have another variable called sum equal to 0. Okay. Nonce. This one is nonce. Let's say if sum plus none greater than target, that means we need to have the count use a new count, right? New count. Let's get this count from 1, right? Because at least we'll use a 1. If this one greater than this one, I have new count. So here we can terminate if the count is already greater than k, we just return false, okay? And we are going to have sum equal to 0, okay? And otherwise we're just sum plus equal to 9. In any case, to have sum plus equal to 9. In the end, we definitely return true. So this is the binary search for this question. Trying to see need is valid. Not find single is valid. Is valid. Okay. And so can see. So doing like a bound research, we have log max, right? Log max operations. This is because the max determining on the biggest number of it. So this is for example, we have log max, and there are n numbers to trying to compare, right? So it will be n log here this is the n operation, right? So this is the log max operation. This is the n log operation. Also for base or space, there is no extra space. We didn't see extra space, right?